Chemistry is the study of, some people say chemicals. A more technical term is matter, and you know what matter is. It's anything that has mass and occupies space. Mass we measure in grams. It's the basic unit. And mass is actually the quantity of matter. So if you want to know how much matter something contains, you put it on a balance and get its mass. That brings up the law of conservation of mass. In a chemical change, the total mass remains the same. In other words, mass is not gained or lost. This term, chemical change, has another word that we use. It's chemical reaction. And that's what we say most of the time. Chemical reaction, or just reaction, is sometimes abbreviated RXN. Let's look at a chemical reaction. Here's one where we're burning gasoline to make carbon dioxide and water. Burning means combining chemically with oxygen. Let me add some numbers on here for the, I've got the volumes. Let's add some of the masses here. So that we have the volume and the mass of some of the substances anyway. So I've given you the mass of one reactant and two products. Let's see if we can answer these questions. So the first question is, I want to know how many grams of oxygen were used. And this is where I use the law of conservation of mass, that no matter is destroyed or created, so the mass has to be the same. In other words, the total mass here has to be the same as the total mass before the reaction occurred. So in other words, I could add up the masses of the products. And then subtract the reactant that we know. And I will get the mass that must be oxygen. Okay, so that's simple. We don't have to do any fancy stoichiometry or molar mass or things we're going to do later in the class. That's simple arithmetic. Okay, so which contains the greater amount of matter, the gasoline or the carbon dioxide? So I'm comparing gasoline, carbon dioxide. Which one has the most matter? When I want to measure matter, the quantity of matter, I look only at mass. It doesn't matter how many liters. What matters is mass. So there are actually, there's actually more carbon dioxide because there's more grams. Now it doesn't matter really that the volume is much larger for carbon dioxide. That really doesn't necessarily indicate the amount of matter. Why is the volume of carbon dioxide so large compared to the volume of the gasoline? It has to do with the state of matter. The gasoline is probably a liquid, and so it occupies less space. In a gas, the carbon dioxide molecules are really spread apart, so it occupies more volume. And that's our next topic, the states of matter. See what you remember about these. One is solid, one is gas, and one is liquid. So fixed shape and volume, that's solid. No fixed shape but a fixed volume, that's a liquid. And a shape where the shape nor volume is fixed, that's a gas. Okay, so we should know that. Here's a couple other terms that go along with that. Fluids flow easily. So which of these states of matter flow easily? A lot of times when we think of fluid, we think of liquids, but truly gases flow easily as well. If you study fluid dynamics, like if you're going to be an engineer, you'll learn about the flow of both liquids and gases. Another term that comes up with states of matter is compressible. The volume will decrease when you apply pressure. In other words, you can smush it down into a smaller volume, and gases are known for that. Now you guys, you should know that these are kind of generalizations. Truly, liquids are slightly compressible. Even solids are slightly compressible. But we're saying in general, gases are the most compressible, and that. And we also know that volume can change on a solid. Truly, if you heat up a solid, its volume will change slightly. It will usually get larger. But anyway, so those are the generalizations that we make.